All right, I'm back again and I am taping. And what I'd like to do right now is to go over chapter 17. Now, I should mention to you, will you be responsible for this stuff? Yes, but not for the next test. We have now gone through again all of sections 1, 2, and 3. So we're going to be working on now section 4, which is all the stuff that you see in here. Today, since it's a shorter chapter, about 20 pages, I'd like to go over file IO. We're not going to concentrate very much on that. We will look at a problem or two, but we are going to concentrate a lot on link next week. Tuesday, Wednesday, and Thursday of next week, we're going to concentrate almost solely on link there, and that's going to help when you have to do your final project. Then the week after that, which is like the week of the 24th, I believe, we might go over all 4 of these chapters. We might go over 2 or 3. I don't know yet. We'll see how time goes. All right. But the test that you take on Monday, hands-on test number 6, I believe at least, will be your last hands-on test that you'll have to take this semester. I've got a meeting tentatively scheduled with Evan at 12:30 today, and I want to make sure that that's the way I'm supposed to be doing this. All right. Now, the other thing I want to mention before we go over chapter 17 is when you look here, all right, we've got extra exercises and we've got these projects. I am not making you do any of these projects for chapters 12 through 16. You don't have to do any of them. All right. So with that said, under the extra exercises, this is what is due, and it's due on Sunday of this week. We're talking 4 days from now. Now, I've done all these for you. The lecture yesterday that you got in the afternoon, it was 2 hours and some minutes long, was private. All right. I went over 12.1 and I went over 14.1 and I went over 15.1 and I went over 16.1 and 16.2. I'm going to repeat those on here right now just so you see all of them. That means 12.1, I'll make this bigger in a second, 14.1, 15.1, 16.1, and 16.2, plus the written tests for 12, 14, 15, and 16. Let's make this bigger so you can actually read it. So your homework for Sunday will be extra exercises, 12.1, 14.1, 15.1, 16.1, and 16.2. Let me double check, make sure those are all the right ones. So 12.1 is create and use a class. 14.1 is use inheritance. 15.1 is create and use an interface. 16.1 is add XML documentation to a class. 16.2 is create and use a class library. So in other words, those are your extra exercises, which we typically refer to as homework. All right. Extra exercises. All right. Now for labs, none. You're not being assigned any labs. Written tests, you must do the written tests for 12, 14, 15, and 16. So this is the stuff right there. I'll leave that up there for a second. So there's 5 homework problems you have to do. And again, I did those yesterday. You basically have to replicate those yourselves. all right? And the written tests, which you're doing on your own, but there will be no labs. I am not sure. All right, there will probably be some work. I don't know what it'll be that will be due Sunday the 23rd. And I don't know what it'll be. So it's going to be probably something from chapter 17 and probably something from chapter 18. At a minimum, it'll be the written tests for chapters 17 and 18. I don't know what, because I haven't looked at the homework and the labs for 17 and 18. We'll probably end up doing another problem or two in class, like the photo one that we did, and like the letter and certified letter one that we did. All right, so with that said, let me jump into the chapter. All right, so this is section 4. It says basic skills for working with data. The big thing in this section is we are transitioning over to where we want to be able to, when we create a program, we want to be able to save our output. Right now, every time we've run a console app or every time we go in and we run a GUI app, when we either finish the program or click a clear button, all that information's gone. We want to be able to keep it. So chapter 17 is going to teach us the basics of working with files. There's two basic types of files. They are text files and they are binary files. To show you very simply the difference between them, if I come in here and like this file right here, this is the ones I use every morning when I write your emails, etc. to you. This file is called Summer 2023 Scheduling 1.txt. This is a text file, a TXT file. On the other hand, this PDF right here is not a text file. It's a binary file. So if I come in and try to go in here and open up, for example, all right, so in my text editor, if I do a file open, and I go over here to C:\\Muroc \, and I go down to my, oh, where are you? All right, instructors, C#, student download, let's say, no, let's not do that. Let's go to C# students, extra exercises, and here's that PDF. If I try to open up that PDF, look what happens. You can see some of the letters and words, but this is a binary file, and I'm trying to read a binary file with a text editor. It doesn't work. If I'm the same way, if I try to open the other one, which is the Word file, the same junk. So in other words, the big takeaway right here is text files are just plain text that can be read by a simple text editor. Binary files are not simple text files, so they cannot be read by a simple text editor. All right, so that's what chapter 18 or 17 rather is about. Then next week, like I said, we'll spend a lot of time going over chapter 18. And chapter 18 is going to transition us even further away from files and towards databases, which we will begin not next week, but the following week. All right, LINQ is something that was created by Microsoft to allow you to query, or in other words, if you've got an information source, it could be an array, it could be a list, it could be a database, but you're able to go through that and pick out the information you want. So that's what we're going to be doing starting on Tuesday of next week. So then in here, let's go over right now, between now and around noon or so, maybe it'll be a little later, I don't know. Chapter 17, how to work with file IO. As it says here, in this chapter, you will learn how to work with file input and output. That's what the IO stands for. and how to do it with text files and how to do it with binary files. It says, although binary files are required for some apps, text files are preferred whenever possible because, yeah, they're portable. But even with that platform independent, they can be read with a simple text editor. All right. Now, for example, if I'm using, if I've gone in and I've got somebody sends me a Word document, and let's say I don't have Microsoft Office, can I still read it? The answer is actually yes. But I'll have to go out really to Google Apps and I'll have to find their equivalent of Word in their stuff, and I'd have to read it through there. All right, which is a pain in the butt to do. Okay. All right. It says we'll learn how to work with text files first. That's the first most of the chapter. And then the last few pages, they'll talk about how to work with binary files. All right, so let's get into it. When you work with files and when you work with file programs, what you're going to end up doing, I'm going to put it in here now. All right, and I'm just going to put it in here and I'll remove it right away. But you have a special using statement, which is using system.io. So when you are working with files, you put that in there, in addition to any other using statements you might need. All right, I'm not using it in this program, no pun intended. So I'm just going to leave it. In fact, I'm going to close this now. I don't think I'm going to need this for anything. All right. There, that same space, when you use the using statement, it provides pre-written C# classes that allow you to work with files, with directories, also known as folders, and paths. All right, if you don't know what a path is, you will by the end of the lecture here. As it says, we're going to be introduced to these topics. In addition, we'll talk about files and streams. The way that you do text files and binary files is remarkably similar. It's just with one, you've got to basically specify the word binary in there. And with regular text files, you don't. We'll talk about that in just a bit. So it says here, the next figure summarizes some of these classes. So let's look in here. If you want to work with a directory, or as most of us call them, a folder, all right, you use the directory class. If you want to work with a file, and I think you all know what files are, all right, you work with the file class. If you want to work with a path, which says where something is located, you work with the path class. In fact, now that I think about it, I will bring this back up. And let's see. Oh, for now, I'll just bring the pretest back up. That's fine. But one thing that we talked about in here earlier, I'm not going to go and do this, but if you remember in an earlier chapter, we went into our project and we added a folder that we called images. All right. And we brought images into our program. When we did that, when we brought in an image, we right mouse clicked on the image file and we chose down here, copy full path. In fact, if I do this right now, if I click here, right mouse click and choose copy full path. All right. And then I'm just going to come and show it in here. There's the path. So that's where this file lives. It's on my C drive, under my users folder or directory, under a JP Scott folder or directory, under a desktop folder or directory, under a 6-23- folder or directory, under a CH14-16 pretest folder or directory, under another pretest directory, under another pretest, etc. Then there's the name of the file. So if we were working on this stuff, this would be the path right there, and this would be the file. Now, when you think about it with a path, what this is saying is I've got a folder on my C drive named users. Under that folder, I've got another folder named JP Scott. Under that folder, I've got another folder named desktop, etc. All right, so that's what we're talking about in here. Now, when you're working with this stuff, if you look there under these common methods, the first one says exists. All right. Well, if I'm going to go and copy something into a directory, I might want to see if that directory name already exists, or if I'm going to copy a file in, I might want to see if that file already exists. If the folder or directory doesn't exist, I can create it with a create directory and tell it exactly where I want it to be created. If I want to delete a directory, I give it the path and the name. Notice the directory must be empty before I can delete it, unless I use the delete with the recursive. That says I don't care. Delete that folder and any folders or any files that are in it. All right. And then finally, we've got some methods of the file class. You'll notice again, there's another exists. Notice it exists in this case and exists up here. They both return Boolean. Returns true for the directory if the directory exists. Here it returns true if the file exists. They both have a delete, and they both require the path to make sure you know exactly what it is you want to delete. In addition, the file class has a copy method, which allows you to copy the file from the source to the destination or move it from the source to the destination. And then they show you some examples of these. Now, the majority of the work you probably will do as a C# programmer, you'll probably be working relatively infrequently, so not frequently, not with files. You'll be working more frequently with databases. And the good news is with databases, by and large, you're not going to have to go through most of this stuff. So I'm going to make sure that whatever we do for homework and for labs in here. So I'm going to look at these two things for chapter 17, and I don't know if we'll do neither, one, or both. Then I'm going to look at the one in here, and these projects in here, that has nothing to do with files and link. So the only work that we might have for chapter 17 would be either, trying to get that back up, 17.1 or 17.2 or both of them. I'm going to look and see how much work is involved with that. I will tell you, we will be doing 18.1 and we'll do that one as class. All right. So as they mention here, the classes for managing directories, and we refer typically to a directory as a folder, but they used to always just be called directories. Files and paths are in the system.io namespace rather. It says Visual Studio 2022 generates a global for this when you create a new project. I wasn't even aware of that. What that means is you don't even have to include it like I did with the using statement. All right, it should be there for us automatically. All of these methods, so everything that you see up here, so for the methods in the directory class, the methods in the file class, all of these methods are static. By now, you should be able to understand that what that means, since they are static, is you do not have to create an instance of a directory class or an instance of a file class or an instance of a path class. All right. So how do files and streams work? It says when you use system IO to do input-output operations, you've got text files and you've got binary files. I already showed you the difference. This is what they're doing. So there's a text file, there's a binary file, and it's basically you can see some of it looks garbagey, etc. So a text file, as they say there, it's a file that just contains characters. The fields are typically delimited by a special character. It could be a tab, it could be a pipe, it could be a line break like you hit enter. All right. The records are typically delimited by new line characters. Binary, as it says, it can contain a lot of different data types. So we use the text stream when we're working with text data and the file stream when we're working with binary data. But look in here. Notice that when we are working with input and output files, we use a file stream. But when we're working with text files, we do a stream reader or a stream writer. When we're working with binary files, we use a binary reader or a binary writer. All right. So as it says, an input file is a file that is read in by the program. An output file is a file that's written to by the program. So I/O operations are typically called file I/O. All right. And where they say here, a stream is the flow of data from one location to another. I've seen it actually put like it's like a hose. When you turn the water on and it shoots out, that's the stream. And if you look at that with a file, that's the stream of data. All right. When you are writing data, it is an output stream. The actual default output device is the one we've been using the entire semester, and that is your screen. To read data, you use an input stream. We've been using the default one all semester, and that's been our keyboard. But you can set either your input stream or your output stream or both, or if you know the way we've been doing, neither, but you can set them to files as well. So as it says there, to read and to write text files, you use text streams. All right. Streams. To read and write binary files, you use binary streams. All right. But they're used very much in a similar way. All right. So the next thing in there, as it says, is it says to create a stream that connects to a file, you use the file stream class as is shown. So let's look at it. Right there. Now there's a lot of stuff in there, then a lot of it might not make sense. So let's break it down. Notice that file stream, we're creating a file stream object, new file stream. We're giving it a path, which is saying if we're going to create a new file, where we want it to be created. Then we've got a mode. All right. And that mode basically says, all right, how we want to open this file. What does that mean? Well, notice the modes that are shown there in the first table. Append. What append does is it assumes that the file already exists. It opens the file and it moves what's called the file pointer to the end of the file. It just moves to the end of the file automatically. All right. And then it starts to write. If the file doesn't exist, it creates it. All right. And it moves the file pointer to the beginning of the file. And to use append, the access must be right. Okay. Create is a dangerous one. Create creates a new file. But if that file already exists, it takes what's called that file pointer and it points it to the beginning of the file and it overwrites whatever was there. Because I've had this happen before where students have done a create where they didn't mean to. And they're like, hey, I gave it a name of a file I already had, and the new file only has a line in it. The old file had hundreds of lines in it, but I can't bring the old file back. It's because you overwrote the old one. So typically, rather than create, you use create new. Notice with a create new, all right, if the file already exists and you try doing a create new, it'll throw an exception. So you'll put that typically inside of a try catch block. All right. So those are appending, create, and create. Those are basically when we want to not read, that's when we want to write. When we want to read, we're typically going to use open, as it says. Just open opens an existing file. And again, if that file does not exist, it'll throw an exception. So again, you'd oftentimes do this inside of a try-catch block. Open or create says, open a file if it exists, and if it doesn't exist, create a new file by that name. All right. And truncate says basically you're opening it, it's an existing file, file pointer to the beginning so that it has no size. Notice that when you read these, you've got three types of access. Read means that it's read only, so you can read from the file, but you can't write to it. Write, which means it's write only, which means you can write to the file, but not read from it. And probably the one that's used most often, which is read write, where you can read data from the file and write data to the file. And you'll notice that's used so often that that's the default. All right. The file share is going to be most important when you're either working with other people or you want to be able to take a file and have it be opened in different applications. So I'm not even going to go over file share. All right. A common method of the file stream class is close. But if you run a program and you open a file and do some work with it and forget to close it, when the program closes, the file is automatically closed. That said, it is still considered good practice to call the close method, as it closes the stream and it releases any resources associated with it. So here's the first time you're seeing something. Notice that we're creating a file stream object, but before we do that, we're setting up a path. So we're saying, and we got that @ sign there, you've seen that before, so we can use the backslashes. This is saying our path is going to be on the C drive. There'll be a folder called C#. There'll be a folder underneath that called files. And underneath the files folder, there'll be a file itself, not a folder, but a file called products.txt. Since it's a text file, we'll be able to use the stream reader and stream writer with it. But we're setting up a file stream object there. We're giving it the path that we just set up. We're setting the file mode to create. So again, notice with create, like we talked about, it'll create a new file. If it already exists, it's going to overwrite it. And the access will be write. Here is creating one for reading. So you set the path up the same way. The only thing that changes in here is instead of file mode.create, it becomes file mode.open. And instead of file access.write, it becomes file access.read. Now it says here, operating system level permissions may limit which file access and file share options you use. I've given this kind of example before, but if I go out right now and I go to insiderankin.org, I have absolutely no idea if this is what yours looks like when you go out to Inside Rankin or not. Not to be funny or mean, I don't care. But once I log in, all right, I'm sure that the information that I have here will be different than yours. When I go to academics, here's the information about your class. I'm not going to open anything. And then it's got my information about what I'll be teaching in fall. All right. But the point is this: if I'm someone who works in the payroll department at Rankin Technical College and I go out to Inside Rankin, their view is going to be different than my view here because they're privy to information I'm not privy to. I might be able to go to home and find out some information there about me. I don't know. But I'm not going to be able to see payroll information for other people, etc. All right. Okay. And that's when they're talking about permissions, may limit what you can and cannot do. All right. So how to use the exception classes for file IO. It says back in chapter 7, we worked on exceptions. Now the next table shows you some of the things that you can get. Those are the 4 exceptions that are going to be thrown most often. All right. Some of them probably make sense. Directory not found exception, if you gave it a wrong path, or you gave it a path that's non-existent, or you didn't have access to, or whatever, you'll get a directory not found exception. File not found, same kind of thing. Maybe you gave it the right path, but maybe you told it to open a file that doesn't exist, or whatever. End of stream exception occurs when you attempt to read beyond the end of the file, and the one you'd probably get most often is the first one, an IO exception, which means that something went wrong, all right, when you try to process a stream or a file or a directory. That's why, again, as you can see in the example here on page 561, that typically you're going to put this thing into a try catch block. So you'll notice outside of the block, you're creating a directory path. So we're creating our path. Then our file path is that directory path plus the name of the file. Then we set fs, which is going to be our file stream, equal to null, so it's not set up to anything. Here we're trying to come in and create that file. If for some reason we can't do it, we might get a file not found, a directory not found. The IO exception, to my knowledge, this is more general than these 3. I don't think the order, if you're going to list all 4 of these, I don't think the order of the bottom 3 would matter, but that one should be last. IO exception, because I think that's the most generic out of them. All right. So as it says on the bottom of the page here, if you want to be able to catch any IO exception, anything, you can use, and really this will catch probably anything that goes wrong. Any of these, if you don't put them in, if one of these exceptions would be thrown, it'll be caught here. All right. So to catch the specific exceptions, you can use those other 3, as they mentioned. Okay. So the next 7 or 8 pages, 4 or 5 pages, whatever it is, are going to talk about text files. Then the last 3 or 4 pages will talk about binary files. All right. So as it says here, to read and write characters in a text file, you use Stream Reader and Stream Writer. We've already looked at the file stream, but we're going to look at Stream Writer and Stream Reader right now. So let's go to here. So you'll notice when you make a new Stream Reader object here, this looks a little weird. If you take a look at this line that's right here, see, hard to highlight just that, but the line that's right here, this one, it looks a little weird because what you do when you create a Stream Reader or a Stream Writer object, wrap it inside, or you wrap inside of it a file stream. So you set up the file stream, and then you put it on the outside, a Stream Writer or a Stream Reader. All right. And you might say, "What is this? Do I need to care?" Yes, if you're going to work with files, you do. Take a look at that for each loop that's in here. This is the same, yet different than what we've done. You've always done a console.write or a console.write line, or if we had that using statement where we did the using static system.console, we just used write or we used write line. So if you either do it with a console.write or a console.write line or a write or write line, it uses the default output stream, which is your screen. Here, we're saying text out, that's going to be a file. So this is going to permanently save this information to a file. You may or may not remember, but when we were going through some of those examples in chapters 12 and 14, when we worked with just straight classes and we worked with inheritance, all right, we had that time in there where we had text files we were using. That's pretty much what they're having here. So we would write for each record in the file, we would write the code followed by a pipe sign, followed by the description and a pipe sign, and then followed by the price. Since these both have writes on them and the last one has a write line, the code, the description, and the price will all be put on the same line. And then once the price has been written, you'll go down to the next line. And you'll also notice if you look in here that when you're all done, so once you fall out of the loop, you close, all right, you close your stream writer. Okay. So as the author says here, you can use the write and write line methods of a stream writer object to write data to a text file. We're going to see read in the next page. All right. If the data type that's passed isn't already a string, these will call the toString method and convert it. So basically, everything in a simple text file, they're all characters and strings. All right. If the fields that make up a record, which is like a line of text that you want to print out, are stored in individual variables, you concatenate them together. Up above in the for each loop, we're concatenating them together. And the character we're using in between, or our delimiter, is the pipe sign. All right. Write keeps you on the same line. Write line after it writes, it moves you to a new line. Okay, so that was writing. Then next is reading. And you'll notice we want to then create a stream reader object. And again, we can use the file object as an argument. All right. So it's going to be a new stream reader. But again, we are wrapping inside of there a file stream. Now, this is different. And if we look at these methods, these are the ones you're going to be using virtually all the time. The first method that's shown in there is called peek, P-E-E-K, and it's what's referred to as a look ahead. So what it does is as you're reading the file, it's going to go and look at the next character. If the next character, if there isn't anything, meaning you've reached the end of your file, it'll returns other than negative rather than the file. So that's how you can use peek. And they will show it down here and we'll go through it in just a minute. Read, as it says, reads at a character at a time. Read line, reads a line at a time, or sometimes referred to as a record at a time. Read to end, from where you currently are in the file, it reads to the end of the file, and close we've already talked about. So if we look at this example here, again, notice that we are creating a brand new stream reader. All right, we just did a stream writer on the previous page, but now we're opening this up. We're saying open or create, which means if it didn't exist, create it, but open it up with read access. All right, then what we're doing in here is this list of products. We are reading from a file and we are populating that list of products by grabbing what was in the file. Okay, hopefully that makes at least a little bit of sense to you. And as they mention here, you use a stream reader object to read data from a text file, whereas just previously we used a stream writer object to write data to a text file. All right, and then as they mention here, because the records in most text files end with a line terminator, all right, usually a carriage return or a carriage return in a line feed, you typically use read line to read a record or a line of text at a time. All right, if the fields are delimited by special characters, you'll need to parse them. All right, and yeah, you can look at chapter 9 to do that, I guess. Finally, we use peak as a look ahead to see if we've reached the end. That's what this is doing here, while not equal to -1. So we've got more to read, so keep reading. All right. Now, good, bad, or indifferent, there are some shortcuts that have been created that you can use that are called this using statement and the using declaration. I'm going to say something to you right now. I could be wrong. I'm saying something to you right now. I could be wrong. I believe we can't use these because we're actually using an older version. I didn't realize it when I had you bring this stuff up, but I believe we're using like version 4.7.2. So this is the using was introduced in chapter 8, so I don't think we can use that, no pun intended. All right. But what it does is it allows you to collapse some of your logic. All right. So you'll notice inside of this using statement, we are both creating a stream writer and we are writing all in the same thing, as opposed to the way they showed it before, where we're doing it in a different operation. All right, so there's a method that uses it, and here is the same one. All right, and they've got, notice the difference in here. Here we've got using, and there's a curly, and everything is inside of here. Here we've got a using without a curly, so this is done by itself. You can try using, you can try to work with these using declarations and using statements. I don't think they will work for us. I apologize for that. All right. As it says here, the using statement causes any resources used by an object to be released from memory when it goes out of scope. It's considered a better way of doing it because usually it involves less code and usually it works a little slicker. All right. I'll just leave it at that. All right, so here's a class that works with a text file. We really don't have that much left in the chapter, probably less than 10 pages. All right, so it says in 12, you learn how to develop an app that used a business class named product. You also learn how to use two static methods in the database called productDB to get the data. Well, what they're saying is now, ideally at least, when you look at this, you should be able to understand what's going on in here. All right, so what are we doing in this product DB? Well, we're setting up a directory. All right, to that directory, we are appending the name of the file. So the directory is shown in the first line here. Then when we append the file name to the directory, all right, we've got our path and then the separator. So what we're using in between things that we read is the pipe sign. All right. Then we've got this list of products. And again, what this is doing for us is it's saying we want to iterate or go through our list of products which exists in a file, and we want to be able to work with them in our program. I can't make it any clearer than that. So if that doesn't make a lot of sense, all right, go back and reread the chapter again, I guess. All right, the last 3 or 4 pages that are in here are going to talk about binary files. So as it says, to read and write data in a binary file rather than the stream reader and stream writer, you use binary reader and binary writer. So when we look at this, it's going to look very similar where before we had a stream reader and we wrapped inside of that a file stream. Now we've got I'm sorry, before we had a stream writer and we wrapped inside of that a file stream. Now we've got a binary writer and we're wrapping inside of that a file stream. All right. That's really the big difference in here. But the big thing is with a binary file cannot be read. I'm going to say this again. A binary file, typically at least, cannot be read using a simple text editor or if you try to read it with a simple text editor, it's going to look all jumbled. It just won't look the way you think it would or should look. So as they mention here, you use a binary writer object to write data to a binary file. In most cases, it says you'll write one field at a time in some kind of sequence. The binary class is more simplistic in this way in that it provides a single write method for writing data to a file. It determines the type of data being written based on the data type of the argument you give it. So here's an example of reading a binary file. And again, you'll notice some of these methods are similar to what we had before. Instead of peek, it's peek char. All right. And you'll notice read Boolean, read byte, read char, read decimal, read in32, read string. What are we attempting to do there? We're attempting to read a Boolean value or a byte value, and a byte is just a very small integer, a single character, a decimal value, an integer value, a string value. All right. And that's it. So again, when you look at this, this is going to look similar to the example we saw previously with the stream reader. All right. Now, again, we use peek char instead of peek, but in a binary reader instead of stream reader. But again, we are wrapping inside of there the file stream object. All right. So as they mention here, you use a binary reader object to read a single character or an entire field from a binary file. To read a single character, you use the read method, so you'd put it in some kind of a loop. To read a field, you use the method that indicates the type of data. So one of these. So this will read the next character. This will read the next value. All right, which is typically going to be more than one character. And again, you use the peek char to determine if you're at the end of the stream. All right, so they go back and they do that same class that they showed before, but they do it using a binary file. All right. My guess is, and I'm going to look at these this weekend because we're done with the chapter now, but my guess is I'm going to look at these this weekend, and I'm guessing here that if we do either of these, we'll probably just do the one for the text file. All right. And again, we'll do that together next week. I don't think it's going to be that tough. All right. I don't really feel like working with binary files. But again, we will do this link exercise that is in chapter 18. So before I let you go, all right, tomorrow is a lab for the entire period. I will be online for the entire period. Not in Teams, but I'll be online. I'll be right here, sitting in where I'm always doing my lectures from. If you have questions, you can email me at jpscott@rankin.edu. If the questions are that extensive, we can even set up a Teams meeting if we need to do so. All right, so that'll be tomorrow. You already know, we talked about this previously, that again, where are you? There you are. This is what's due on Sunday. From the extra exercises, 12.1, using classes, 14.1, which is inheritance, 15.1, which is on interfaces, 16.1, which is on XML documentation, and 16.2 on class libraries. There will be no labs due. You must turn in the 4 written tests for 12, 14, 15, and 16. That is what is due this Sunday. This one, I'll go and update this at a later time. So Monday of next week will be your number 6 and probably at least your last hands-on test. When you take that, it'll be the same format and same stuff as we've been doing. By 7 a.m. Monday, I will email you the test. At 8 a.m. on Monday till about 8:15 or longer if we need it, I will go over what the test is about. All right. And you'll have the rest of the day to work on it and have that test turned in. Now, for those of you, I mean, some of you have been turning in tests late or thinking, hey, I did it, but I'm going to turn in something the next day and I'll have it even better. No, no more of that. None. Whatever you turn in by midnight is what I'm grading. All right. And unless you're sick or you're in an accident or whatever, it's due by midnight. All right. And I will try to grade it already by Tuesday. But if you don't have anything done, you get a 0. I don't have time to keep regrading things and doing whatever. And it's also not fair to those students who are doing things the right way. All right. So whatever we do for chapter 17 will be very limited from now on. We may do that example 17.1, and we'll do that maybe Wednesday of next like that. But we will take quite a bit of time to go over link. All right. And that'll be Tuesday, probably the whole period, even though it's not a super long chapter. This is a complex topic. All right. Finally, and I can send you these. All I did was I went to learn.microsoft.com and did some Googling. This is pretty good. I read this morning. Use Visual C# to do basic file IO. I'll try to remember to include that link, all right, into the email I'll send you later today. And this, all I did was I checked link, and there's a lot of stuff in here. Because you can do link in a lot of ways. All right. I would say to start with, I'd read the introduction to link queries and then go into the link in C# and the language integrated query. That's what link stands for in C#. All right. So again, last time, this is it for today. Tomorrow will be lab. I'll be online. All right. The entire period. You won't get an email from me tomorrow. You won't get a morning email or an afternoon email from me because it's a lab day. You know now what work is due by Sunday. Monday of next week will be the hands-on test. Tuesday of next week, we're going to start the period by going over chapter 18 on link, and we'll see exactly where we are by then. All right. My hope is if we spend all day or most of the period on that between Tuesday and Wednesday, all right, we can get done with some link examples and maybe a file example. And then on Thursday, rather than a test, I might give you a worksheet where you can practice using link because you need some practice with it before we go on to databases in the following week. All right. If you have any questions, as always, please email me at jpscott@rankin.edu. With that said, have a great rest of the day, and I will talk to you then Monday. See you.